Hi, my name is Rinkesh Patil. I'm a student of MWS program. I'm here to present a case study describing the development of environmental flow rules for the river Ganges in its upper basin. This presentation is based on assessment of environmental flows for the Upper Ganga Basin summary report published by World Wildlife Federation in 2012. As per the definition provided in this report, environmental flows are the flows required for the maintenance of the ecological integrity of the river, their associated ecosystems, and the goods and services provided by them. Environmental flows are increasingly recognized as a vital contributor to the continuing provision of environmental goods and services upon which people's lives and livelihood depends. It is needed for maintaining river regimes. By river regimes here, I mean a set pattern formed by rivers' flows and levels over time to which the biology and we as a humans have evolved to. It also is required for making rivers self-purify itself, maintaining aquatic biodiversity, recharging groundwater, supporting livelihoods, maintaining sediment movement, preventing saline intrusions in estuaries and delta areas, providing recreation, and allowing the river to play its role in fulfilling the cultural and spiritual needs of the people. The Ganga, or better known as the Ganges, origins from Gangotri Glacier in Himalayan mountain range in India and it flows into Bay of Bengal. Its course of around 2,500 kilometers possesses of extraordinary varieties in altitude, climate, land use, flora and fauna, social and cultural lives. It is the most sacred river in India, given a status of a goddess, and is deeply revered by the people of this country. Its river basin constitutes 26% of India's landmass and supports 43% of its total population of 1.3 billion people. This growing population exerts enormous pressure on this river basin through rapid urbanization, industrialization, and increasingly growing irrigational demand. Given the complex nature of the river, holistic methodologies are more suited for assessment of environmental flows. This would not only consider scientific and technical aspects, but also cultural, social, economic, and environmental aspects. One such method, called VBM building block methodology, was selected for its flexible, participatory, and robust multidisciplinary nature. BBM is based on number one, using a stakeholder consultation process to set objectives for the environmental condition of the river. Number two, assessing a modified flow regime that will meet those objectives. Number three, using flow dependent indicators like the species that live in the river regimes, like river dolphin, turtles, fishes, floodplain plants, etc., non-consumptive human requirements, sediment transport, and water quality metrics to set hydraulic parameters like water depth, velocity, river width, and substrate type to provide habitats. Then these parameters can later be converted to hydrological requirements. And number four, lastly, it's based on identifying critical components of flow regime that govern the environmental conditions. We can say, for example, dry and wet seasonal uh, base-like flow, different sized high flows and floods. Now coming to process of assessment, experts from various areas, namely hydrology, engineering, hydraulics, biodiversity, and social scientists, analyzed the entire stretch of river in its upper basin from Gangotri in mountainous Himalayas to a city called Kanpur in the floodplains. Um, Later, sensitive biodiversities areas were identified, and eventually entire upper basin was divided into four zones, starting from upstream to downstream. Zone 1 is from Gangotri to Rishikesh, with a site at Kaudiala. Here, site is an area selected within zone to carry analysis and research. Now we go downstream to zone 2, Garmukteshwar to Narora, with the site at Narora. This zone is a reference zone. A reference zone is a zone which one would ideally refer to for various aspects, activities, requirements. This zone has water volumes maintained at an optimum level to supply a nuclear power plant downstream. As this is a reference zone, there won't be much analysis for this zone. And now going further to downstream, zone 3, uh, that's from Narora to Farrukhabad, with site at Kachla Ghat. And then finally zone 4, that's from Kannauj to Kanpur. Experts held workshops to define ecological management classes, EMC, based on set objectives. The range of classes went from A to D. Moreover, to determine river conditions, classes A to F were set. This would be used to recognize present ecological state, PES. As seen, the river health deteriorates going from class A to F, uh, where class A is close to natural condition, and further when we go from class B, C, D, and E, the river condition deteriorates. Class E and F are no longer providing sustainable services. To ease and better manage the assessment process, subtasks were defined for detailed studies, as can be seen in the slide. Experts and working groups were assigned to each subtask, and as a part of workshop, terms of reference for various subtasks were discussed, drafted, finalized, and shared. So further proceedings began with the generation of hydrological report of the basin based on field measurements, past data, and modeling. So basic aim here was to understand the basin and its generated flows in naturalized conditions. That is, how would flows be without any dams or irrigation canals or other sort of infrastructure on it. For later part of proceedings, for more than a year, all experts and working groups were engaged in baseline data collection, sampling, surveying at various sites. Later than these findings were discussed amongst different groups at workshop on how the e-flows would be set it up. It consisted of present and desired condition of river Ganges as per the requirements of each component. So various aspects were discussed, and which group requires what volume of water for what time of year. So everything was discussed there. And also different flows were recommended for dry and wet seasons, flood and drought years, uh, so that the minimum flow can be maintained to satisfy all aspects. Now, let's try to understand some of the aspects and its flow requirements. Let's start with cultural and spiritual needs. The image shown here is from a town called Rishikesh, where thousands of pilgrims visit every day to worship along the banks of river. They offer flowers, fruits, and other offerings to the river as a part of worship. Hence, the flow requirement at Kaudilia in Zone 1, very close to Rishikesh, uh, it should be enough to avoid debris and sediment built up on steps going to river, especially during drought years. It should be clean enough for bathing and worship. Um, One thing observed is that flow desired is not on a functional demand. For example, you don't need much volume of water or much flow of water to perform most of the rituals. But it's more of a emotional and subjective need based on perception of what mighty goddess river ought to be like. Zone 3 has many towns where people from a religious group perform cremation rituals and have a dip in river after rituals are performed, as can be seen in the image. So flows have to be enough to perform those rituals. That is, the flows have to be close to what historical water flows have been. In earlier slides, as I mentioned, this one is a classic example of how we as a society have evolved based on flow regimes. These places were chosen in past to perform particular rituals based on the regimes river provided to them. In Zone 4, in city of Bitur, local community expects the temple on banks of river to be inundated in monsoon. This is seen as a part of uh, cleansing cleansing ritual. While this might not occur throughout the monsoon, it does need to occur at least once a year as an expected and welcome event of the year for the local people. So in long term, for all three zones, ecological management class of A should be aimed. That is where the river conditions are close to being natural. But in short term, EMC of B would be acceptable. That is the natural condition with minor changes to it. With respect to fluid geomorphical aspect, longitudinal connectivity and lateral connectivity of river are key considerations for flow and sediment transport. They are crucial for maintenance of ecological systems. The flow should maintain the complexity of river channel form in terms of bar types, sinuosity, poor riffle sequence, etc., which favor ecological diversity. And the floods are often seen as destructive, but they are very essential for overall health of the river and its floodplain. For biodiversity requirements of environmental flows, the key criteria here was survival of flagship species, which includes mashir. It's a species of fish indigenous to Gangetic uh, basin. Snow trout, otter, dolphin, gharial. Gharial is a member of crocodile family. Well, quite smaller in stature, as can be seen in the image on the top. As well as other fishes, invertebrates, and diatoms, which sustain biodiversity and food web so that the aquatic and associated floodplain ecosystem remains intact. Also, there is a need to restore some flow variability, which maintains natural biodiversity and inhibits proliferation of invasive species resulting from change in flow regime. For example, in absence of recommended flows at Caudilia in Zone 1, the natural riparian flora faces unusual competition for resources and nutrients from alien plant species. Here, the emphasis on importance of flood and flow variability uh, is made, which is quite needed to distribute the much needed silt and nutrients onto the floodplain and keep the biodiversity intact. Meet the livelihood needs of the people who actually depend on river system. Adequate flows are needed to facilitate activities like whitewater rafting in Zone 1. Well, floods do affect the tourism related business some years, but it also enhances beach camping activities by bringing good sand formation after the floods. In Zone 3 and 4, there are people who depend on fishing and ferry transport business for livelihood, and even those businesses are affected during the floods. And same community of people are allowed riverbed farming during the drought season by the government just to facilitate them with some earnings. As far as the water quality is concerned, Zone 1 is classified in Class A for present ecological condition, that is, water is drinkable quality with added chlorination. For Zone 3, it has presence of high organics and coliforms, primarily due to inefficient sewage treatment systems in towns and cities through which the river passes. Recommended environmental flows and upgradation of sewage plants is expected to improve the water quality in Zone 3. Um, for Zone 4, Water quality is a real concern. Here, river is heavily polluted due to the tributaries, which bring loads of pollutants with them, and it gets added to the main river. Also, many point and non-point sources are responsible. The water quality here is aimed to bring it to class B. So before we jump on to key findings and recommendations, let's revise a couple of definitions. So the the flows needed during normal years for proper functioning of ecological processes. These are defined as maintenance flows, and the minimum flows required for habitat and survival conditions are defined as drought flows. These definitions would be very helpful, yeah, in further evaluations of key findings. And one thing more to consider is for long-term environmental flows, the water volume required would be at maintenance recommendations or higher for 70% of time, and between drought and maintenance for 30% of time. The figure on the right presents the monthly environmental flows requirements for both low flow as well as high flow maintenance for zone 1. The naturalized flows are also plotted in the light pink color in the figure on the right. The naturalized flows are the flows that would have been occurred historically in absence of any reservoirs, water supply diversions, and return flows and other type of water management activities that are reflected in present day input data set. And the environmental flows requirements or the maintenance flow requirements were calculated as 72% of natural mean annual runoff. The definition for maintenance flows was discussed in the previous slide. The mean annual runoff is the average volume of water flowing through that site in the river flowing in a year. It was calculated 72%, which is shown in the figure on the right. The drought flows were also calculated to be 44% of natural mean annual runoff, which is not shown in the figure, but it's 44%. And while recommending the final flows, stakeholders from all the groups were considered for their requirements as shown in the slide. And one key consideration for the results of zone 1 is that no data was available to calculate the present day flow. The data is available from a dam, and the data is not available to public due to security concerns. Now let's jump on to zone 2. For zone 3, as shown in figure on the right, the E-flows or maintenance flows were calculated as 45% of natural annual runoff, whereas the drought flows were calculated to be 18% of natural mean annual runoffs. The figure also presents the naturalized flows as well as the simulated present day flows. The data was available, so the present day flows were able to be calculated as seen in the line. The above mentioned flows here are necessary, especially during the lean season, for sustenance of biodiversity, which includes survival of endangered species like gharial, gangetic dolphin, and other vertebrates like otter, turtles, as well as sustaining fisheries. The predicted wet season flows are essential for successful spawning of carps and maintaining riparian cover, which is also very important for spawning of the fishes. For zone 4, the environmental flows or maintenance flows were calculated as 47% of natural mean annual runoff, whereas the drought flows were calculated as 14% of natural mean annual runoff. Also, it is seen that the present day flows are lower than the environmental flows required in all the dry seasons of the month. This was also observed in zone 3. The proposed environmental flows here are quite necessary from biodiversity point of view, especially the dry months of January, February, and March. These minimum flows are very important for critically endangered species, and also maintaining high flows in the wet season is important for good fisheries. To conclude, the BBM methodology was assessed as robust, and the level of confidence was very high with all the experts. However, the experts rated the overall assessment of Ganges based on the BBM methodology as a bit unsatisfactory. So they rated it 3 out of 5. They were less confident about specific flows recommended at each zone. This was primarily because of lack of long-term hydrological records, insufficient cross-sectional data, and uncertain modeling outputs. There just wasn't enough data for hydrological models to uh, validate and calibrate enough times. Also, with respect to the water quality, the impact of recommended flows on diluting the pollution in the river, like would it provide sufficient water quality to enable the survival or recolonization of sensitive species? I mean, this still needs to be studied in detail. Despite all these constraints, uh, it was the first attempt in the country to carry out such a comprehensive assessment of environmental flows. Like all the previous works were mostly desktop works. And overall, it has certainly built a national capacity to conduct further environmental flow assessments, not only for River Ganges, but for other rivers of India. And that's it. Thank you for watching my presentation, and if you have any questions, please reach out with your questions through email, and I would be happy to answer those. And before I end my presentation, I would like to acknowledge all my sources which I used for making of this presentation. Thank you very much.